Hello, Matthews Gatos here. Welcome back to Chapter 7, Rational Equations and Expressions, Lesson 10, the Practice Test, Part 2. Okay, numeric response question 2. We want to simplify this quotient. So using keep, Chewbacca, fly, I am going to keep, change, and flip. So keep my first fraction the same. So that is 7 times x minus 3 all over x plus 7 times x plus 2. Change the division to multiplication and flip the second fraction. So I'm going to write x plus 7 squared as x plus 7 times x plus 7. And then 21 times x minus 3. So I always like to write my monomials as number times variable. Okay, since I'm multiplying, I can just treat this as one big fraction and then look for common factors to cancel. So I have an x minus 3 and an x minus 3. I have an x plus 7 and an x plus 7, an x and an x. And it looks like that's it, so we'll bring them together, which is 7 times x plus 7 over 21 times x plus 2. And then I just look at my numbers, 7 over 21. And in lowest terms, that's 1 over 3. So it's going to be 1 times x plus 7 over 3 times x plus 2. And that's my preferred way of leaving it, but they want it in this form here. So that's just x plus 7 over distributive property, 3x plus 6. So a is the number in front of x in the numerator, 1. B is the constant value in the numerator. C is the number in front of x in the denominator. And 6 is the constant in the denominator. So 1736 would be the answer. Okay, in this question here, we're going to do two-part. We're going to do reducing it and then non-permissible values. So we're looking at product, and product means multiply. So 2x cubed minus 50x. Look at the numbers first. 2 and 50 have a greatest common factor of 2. X cubed and x have a greatest common factor of x. So 2 divided by 2 is 1. X cubed divided by x is x squared minus 50 divided by 2 is 25. And x divided by x is 1. In the denominator, x squared minus 1, that's a difference of squares. So square root of the first term is x, square root of the last term is 1, and add one set and subtract the other, and there's also an x minus 5 there. Now this is going to be multiplied by the second fraction. So they both have 5, so the GCF is 5. One has an x, the other has an x cubed, so it's just x. So 5x divided by 5 is 1, take away. 5 divided by 5 is 1. X cubed divided by x is x squared. And that will be over. Down here, I have a GCF between 5 and 25 of 5. Between x cubed and x squared as x squared, and I'll factor that out. So 5 divided by 5 is 1. X cubed divided by x squared is x plus 25 divided by 5, 5. And then x squared divided by x squared is just 1. So before I go any further, let's do our non-permissible values, which is in number 16. So non-permissible value of a plus 1 is a negative 1. The non-permissible value of a negative 1 is a positive 1. Non-permissible value of negative 5 is positive 5. Non-permissible value of a monomial is 0. And then the non-permissible value of plus 5 is minus 5. So putting this all together, it looks like 0, a positive and negative 1, a positive and negative 5. So looking at that, that would be option number C. Okay, so let's go back up here and we can look at, before I factor further, is there anything that I can simplify? And it does not look like there is. So we have a couple more things to factor. I see a difference of squares here and a difference of squares here. So let's write this out. So 2 times x, I'm actually going to write my monomial as a product. X squared minus 25 is a difference of squares. Square root of the first and last term, add one set, subtract the other. Now this is all one big fraction, so I'm going to multiply it as 5 times x times 1 minus x squared, also a difference of squares. So add one set, subtract the other. The square root of the first term, the square root of the second term. And that will be all over x plus 1 times x minus 1 times x minus 5 times 5x squared, which is 5 times x times x plus 5. So I really like to break my monomials down because I think it makes it easier to simplify. Okay, wow, that's a lot. So let's go ahead and simplify this. So I see an x, and I'll cancel it with an x plus 5, and I'll cancel it with an x plus 5, an x minus 5, and an x minus 5, a 5 and a 5. An x and an x, a 1 plus x and an x plus 1. Those are the same things. And then I have 1 minus x and x minus 1. So remember, when we have same but opposite, those cancel to be just -1. So let me just write this out so I can give myself a little bit more room. In the numerator, I'm left with 2 times 1 minus x all over x minus 1. So here's what I mean. See how I have 1 and -1, negative x and positive x, same but opposite cancels to be -1. So I'm just left with 2 times -1, which is -2. So B would be the answer. Okay, in this one here, we want to find the value of the root. So I have 1 over x minus 4 plus 2 over x plus 4 equals 5 over x squared minus 16. That's a difference of squares. So let's factor it as x minus 4x plus 4. Okay, so I am going to use balance to get rid of this denominator. So looking here, to get rid of this x minus 4, I would multiply everything by x minus 4. That's the balance part. I need to be fair and do it to everything, and it's because I have an equal sign. To get rid of my x plus 4, I would also multiply everything by x plus 4. Okay, so now let's go ahead and simplify. So multiply by x minus 4, divide by x minus 4, I'm left with 1 times x plus 4. Plus, multiply by x plus 4, divide by x plus 4, I'm left with 2 times x minus 4 equals. Now here, everything cancels to be just 5. So I have x plus 4 plus 2x minus 8 equals 5. So x and 2x is 3x. 4 and -8 is -4. So to get x by itself, since it's a linear equation, I add 4 to both sides to get 9, and then I divide both sides by 3 to get x equals 3. So it looks like the value of k, the one solution, is 3. Because this is a numeric response question, I also could have done this on my calculator for a little 1-mark question. So for this question here, if I were to put it into my calculator, let me show you what that would look like. So here I have my left side of my original equation and the right side. I put it into my calculator and I do y1, y2 intersect, and it intersects right here, and you can see that that's at an x value of 3. So I know I did it correctly. Okay, this one here, it has 2 roots, and we're going to find the sum of the roots. So I have 2 over x plus 1 over 6 minus x equals 1. Okay, so I'm going to use balance again. So to get rid of this x, I would multiply everything by x. I have to maintain the balance of the equal sign. To get rid of 6 minus x, I would multiply everything by 6 minus x. And now I simplify. So multiply and divide, I'm left with 2 times 6 minus x plus multiply and divide 1 times x equals 1 times anything is itself, so I'm just left with x times 6 minus x. Let me make that a little neater. Okay, 6 minus x. So here, distributive property, I have 12 minus 2x plus x equals distributive property 6x minus x squared. Okay, so I have 12 minus x, grouping my like terms, equals 6x minus x squared. So I have a quadratic, so I want to set it equal to 0. Since my quadratic starts with a negative leading coefficient, I'm going to add it to this side to make it positive. Okay, so 6x take away 6x is 0, x squared take away x squared is 0. This is all set to 0. So on this side I have x squared, negative 6x, and negative x is negative 7x plus 12. So I just want to factor that because a is equal to 1. So two numbers that multiply to 12 and add to negative 7. So x times x is x squared. And two numbers that multiply to 12 since it's positive and add to a negative, I know both my factors will be negative. And 3 and 4 multiply to 12 and add to 7. So I know that x minus 3 can equal 0, or x minus 4 can equal 0. So adding 3 to both sides, I get x equals 3. Adding 4 to both sides, I get x equal to 4. And they want the sum of the answers. So 3 plus 4 adds to 7. So B would be my answer. But again, if this was a multiple choice question for 1 mark, I am going to put it in my calculator. So let's just look at that. So y1 is the left side of my equation, y2 is the right side of my equation, and I find out where they intersect, and you can see that they intersect at positive 3 and positive 4. Add them together, and that is positive 7. I get the same answer. Okay, in this one here, we are trying to determine the roots of the equation. So, okay, I have a fraction minus a fraction equals 0. The first thing I'm going to do is add 11 over x plus 6 to both sides of the equation. So I add it over here, and then I end up with 4x over 3x plus 4 equals to 11 over x plus 6. So in doing that, I have fraction equal to a fraction, so I can use crisscross. So let's do that. We've got criss, 4x times x plus 6 equals cross 11 times 3x plus 4. So distributive property, I have 4x squared plus 24x equals distributive property, 33x plus 44. So I want to set this equation equal to 0 because it's a quadratic, and then it matches up with what I have over here. So I have my x squared already on one side. So what I'm going to do is subtract 33x from both sides, because that's gone, and subtract 44 from both sides, because then that's gone. So I'm left with 0 over here. So I'm just going to kind of come up here. Let's go up here. So I'm left with 0 on that side, and then I have 4x squared, and then I have 24x, take away 33x is negative 9x, and then take away 44. So that is the quadratic that I end up that I'm going to solve in the next question. But right now, that's what they want, is the a value. That a is the quadratic that matches. So the answer is option A. Okay, let's look at the root of the equation. So they say you can now determine the root of this equation by using the quadratic formula to the quadratic equation. So if I use the quadratic formula on this, I'm going to get my answer. So quadratic formula, first of all, let's label our a, b's, and c's. So a is the number in front of x squared, b is the number in front of x, and c is the number all by itself, the lonely number or the y-intercept. So applying my quadratic formula, x is equal to opposite b, so the opposite of negative 9 is positive 9, plus or minus the square root, b squared minus 4 times a times c, all divided by 2 times a. Okay, so I want to put this together. So under the square root, the discriminant, I'm going to do negative 9 in brackets squared minus 4 times negative 44. And in doing so, underneath the square root, I get 385. So just plugging in this part right here. And that's all over 2 times 4 is 8. So I only want the positive root, so that's just the plus, and then divide by 8. So I just plug this into my calculator. So I'm going to do 9 plus the square root of 785 equals, divided by 8 equals, and I get 4.6 to the nearest tenth. So I know that's what my answer is. Now again, for a 1 mark question, you can also put this into your calculator. So let's look at that option. So putting this into my calculator, I only want the positive root. So here's my equation in y1, 0 in y2. Find out where they intersect. And I just, again, want my positive root, which is, you can see, 4.6. So I know I've done that correctly. Okay, over here, simplified version of subtracting divided by subtracting. Well, order of operations tells us to do inside the brackets first. So I'll do my subtracting first. So to do my subtracting, I need a common denominator. So between 1 and x, my common denominator is x. Between 1 and x squared, my common denominator is x squared. So now I'm going to create equivalent fractions. So to go from 1 to x, I would multiply by x. So to be fair, I will multiply the numerator by x as well to get 6x. This one's already out of x, so I leave it. To go from 1 to x squared, I would multiply numerator and denominator by x squared. And this one's already out of x squared. So now I have 6x minus 2 over x divided by x squared minus 1 over x squared. Okay, so in my numerator number 1, I'm going to factor a GCF of 2. 6x divided by 2 is 3x, minus 2 divided by 2 is 1 over x. And then in my numerator here, I have a difference of squares. So I factor that as x minus 1, x plus 1, and that will be over x squared, which is x times x. Okay, so now I am going to keep Chewbacca fly. Keep my first fraction the way that it is. Change my division to multiplication and flip my second fraction. And then I'm going to look at what I end up getting. Okay, so it's multiplying, so all one big fraction. So multiply by x, divide by x. And let's see, I don't really have anything else, do I? Okay, so let me just look back up here. I feel like I've made a mistake. 3x minus 1. I was really hoping that 3x minus 1 would cancel. But it's not going to cancel. That's okay. So I have 2x times 3x minus 1 all over x minus 1, x plus 1. Okay, let's look at this. This is not feeling right. I feel like I've made a mistake. Let me just go back up here. 2x, 6x minus 2, that's good. Oh, here it is. Here it is, right up here. Of course, it has to be at the very beginning step. Okay, so I need to adjust this. So I have made a boo-boo. Let's erase it. Okay, and that's okay. It happens to all of us. We all make mistakes from time to time, even mosquitoes. So let me just go back over here. That's unfortunate that it was very beginning. See, if I was in class, you guys would tell me I made a mistake, and then I wouldn't have got that far. Okay, x squared times 9 is 9x squared. So let's just try this again. So this is 9x squared over x squared. Okay, so here we go. So the factoring is still going to be the same. Let's go back over here, 9x squared minus 1 over x squared. Okay, so here I have a GCF of 2, and I take that out. I've already done that over x. And I'm going to multiply by the reciprocal because you already saw that step. So multiply by the reciprocal, flip this around, and x squared is x times x. Now, okay, this is a difference of squares still, but there's where my 3x minus 1, because it wasn't going away. So the square root of 9x squared is 3x. And then the square root of 1 is 1. You add one set and subtract the other. Okay, now this looks a lot better. So now I'm going to remove my common factors. So 3x minus 1 and 3x minus 1. And then I have an x and an x. Yes, look at that's much better. So in the numerator, I have 2 times x over in the denominator, 3x plus 1. So B would be my answer. Okay. So again, if you can't do it on the calculator, you can always check it on the calculator, but you could definitely do this question on the calculator. And seeing that I made a silly mistake on it, it would definitely be a good one to do on the calculator. So here's my question in Y1, and I have all of my options for each of the multiple choices. There's A, B, C, and D. And I just look to see which one matches Y1. So what matches Y1, 4 7s and 3, it's this one here. Y1 matches Y3, and Y3 is B, and that's why B is the option. Okay, next one here. So Govinda has a cardiovascular routine, and he is walking for 3 kilometers, running for 6, and then walking for an additional 3. He runs 3 times as fast as he walks, and the total time of his routine is 2 hours. Okay, this is a distance, speed, time question. So I'm going to set it up like that. And he is walking and he is running.
Okay, so remember with these tables, you fill, and calculate. So when he's walking, he walks for 3K and then another 3K, so a total of 6. He runs for 6K. His running speed is 3 times his walking speed. He runs 3 times as fast as he walks. So since I'm comparing running to walking, I'm going to make my walking speed my variable, and my running speed will be 3 times as much, or 3 times x. So I've done the fill. Now I do the calculate. So time is distance divided by speed. And we are told he has a total routine of 2 hours. So that means that my walking speed plus my running speed is equal to 2 hours. Okay, so let's look over here, and we're going to use balance to solve this question. So to get rid of a divide by x, I would multiply everything by x. To get rid of a divide by 3 times x, well, I already have the x, so I'm just going to also multiply everything by 3. So over here, multiply and divide by x, and you can have 6 times 3 is 18, plus multiply and divide by 3x is 6, equals 2 times 3x equals 6x. So I have 6x equals 18 plus 6 is 24. And divide both sides by 6, and I get x equals 4. So that means that my walking speed is 4, and I believe that's what they asked us for. Yes, it is, so it's 4. If I was asked for my running speed, it would just be 3 times 4, which is 12. Okay, 2 whole numbers differ by 3, and their quotient is 3/4. I want to find the sum of the numbers. So 2 whole numbers differ by 3. That means they're 3 apart. So for example, a minus b is 3. Now these are whole numbers, which means they're only positive, which means this, the way I've set it up, is my big number. This, where I set it up, is my small number. So big minus small is 3. Now their quotient is 3/4. So notice the way the quotient is set up, small number on top and big number on bottom is equal to 3/4. So we have to be careful because these are whole numbers. So big minus small equals 3, and then the quotient, which is obviously small over big, equals 3/4. Okay, so I have to narrow it down so I only have one variable. So I'm going to go to my equation here, and I'm going to isolate for one variable. So if I have a minus b equals 3, I'm going to add b to both sides and get a equals 3 plus b. And I'm going to replace that for the a right here. So b over my new a, 3 plus b, equals 3/4. So since I have fraction equal to a fraction, I can use crisscross. So criss equals cross, 3 times 3 plus b. So 4b equals distributive property, 9 plus 3b. And then I will subtract 3b from both sides, and I get b equals 9. So that means that the small number is 9. I have to find the big number, so I'm going to go to this formula here. So a is equal to 3 plus the small number b, which is 9, and 3 plus 9 is 12. So my numbers are 12 and 9, and they want us to do the sum. So 12 plus 9 is 21, and that would be my answer. Okay, what's going on in this one? So we have a rational expression p over qr, and it can be simplified to 1 over 2 times x minus 2, where x cannot equal to plus or minus 2. So the binomial expressions for PR and the constant Q can be selected from the columns below to form a correct simplification. So one possible choice is this one here, and that code is 167. We have to find another one. Okay, so we want the answer to end up being, so I've got, let's set this up here. Where can I set this up? Not a lot of room to write here. So P over Q times R, it's going to equal to 1 over 2 times x minus 2. Now, if you look at the restrictions, I kind of wrote over them, sorry. It's plus and minus 2. So I know on the bottom I have something that's a minus 2 and a plus 2. So if I end up with a minus 2 here, I have to have a minus 2 on the bottom, and I'm also missing a plus 2. Okay, so let's look at the codes for P. Now we can't use the same code that they used. So they used, okay, so they used an x plus 2 on the top. Okay, so we can't use that one. So let's try, these are all variations of x plus 2. Let's try this one, which is 2x plus 4, because this factors as 2 times x plus 2. So let's try that for P, and P is the one on top. So I'm just going to get some different colors going here so we can separate this out. So on the top here, I'm going to put P. So my value for P is going to be 2 times x plus 2. I don't know if this is going to work. We're going to do trial and error. Okay, so I'm trying it with this for P. Okay, now let's go to Q. Q and R are on the bottom. So notice over here I have a 1, so I have to get rid of all of this. And I don't have an x plus 2 here. So I've got to get rid of the x plus 2 here, and I've got to get rid of the 2 as well. So, okay, well, to get rid of the 2, I could definitely use this 2 on the bottom because then they would cancel. Let's just see what my choices are for R. I want to get rid of this x plus 2. So, and I want a 2 on the bottom. So let me think here. What am I going to do? So I am going to try, let's try this one here. No, I'm going to try this one here. So 4 times, take out the 4, x squared minus 4. So 4 divided by 4, 16 divided by 4 is 4. So I'm left with 4 times x minus 2, x plus 2. Let's see if that would work. So if I had that on the bottom, let's just look. So I'm going to erase this. Okay. Let's try putting this one on the bottom. So let me just use a different color here. So I'm going to put this whole thing on the bottom. So on the bottom, I'm going to have 4 times x minus 2, x, oh, that should be a 2, not a 4. Difference of squares, square root, yes, x plus 2. If this was my expression, let's just see, my x plus 2's would cancel. I'd be left with an x minus 2, which is good. And then 2 over 4 in lowest terms is 1 over 2. So if it looked just like that, it would be perfect. So for my Q value, I'm going to choose 1 because I don't want to affect anything. So I'm going to choose it as a 1. This is a really challenging question. Okay, so what I want to do is I want to set this all up together again to show you why it works. Okay, so we're doing P over Q times R. So P, I'm choosing as 2x plus 4 over, and then the code is Q times R. So I'm choosing Q as 1 and R as 4x squared minus 16. So I'm choosing option number 2. I'm choosing option number 5 and option number 9, and I want to show you that it works now. Okay, so first of all, 1 times anything is itself, so it doesn't even need to be considered. Okay, so let's look at what we have. GCF of 2 in the numerator, take that out, is x plus 4. So 2x divided by 2 is x, 4 divided by 2 is 2. In the denominator, I have a GCF of 4. So 4x squared divided by 4 is x squared, minus 16 divided by 4 is 4. Okay, so right now I have 2 over 4 here, and 2 over 4 in lowest terms is 1 over 2. So I have my x plus 2 on the top with a 1, which I don't need to really write. And in the bottom, instead of the 4, you can see I have the 2. And now x squared minus 4 is a difference of squares. So square root of x is x. Square root of 4 is 2. Add one set and subtract the other, and these cancel. So then I am left with 1 over 2 times x minus 2. Is that what I'm supposed to be left with? Yes, it is. Okay, good. So that answer works. Okay, so super challenging question. But again, we wanted to have something different than they do. So you just go with what you want to end up with and work backwards and build up the answer. Okay, now we're into our written response question. So this is a distance, speed, time question. As soon as I see a plane flying, I knew that. So a plane flew from Red Deer to Winnipeg, flying a distance of, okay, so we're going from Red Deer to Winnipeg, and that has a distance of 1,260. So I'm going to set up a distance, speed, time table over here. So I'm going to go Red Deer to Winnipeg, and Winnipeg to Red Deer. Okay, so I'm going to actually just answer this question on the next page and then come back here and fill it all in because they are taking you through this step by step. So let's just go over here. So Red Deer to Winnipeg, distance, speed, time. The distance, 1,260. On the return journey, due to a strong headwind, the plane traveled 1,200 kilometers in the same time it took to complete the outward journey. Okay, so on the outward journey, the plane was able to maintain an average speed of 20 kilometers an hour greater than on the return journey. So we're comparing the outward journey to the return journey. So what I'm going to do is I'm going to keep this as my x, and then it was able to maintain an average speed 20 kilometers an hour greater than the return journey. Actually, I'm going to make my return journey my variable, because on the outward journey, Red Deer to Winnipeg, I went 20 kilometers an hour greater. So it's actually x plus 20. Okay, so I've done fill, and now I need to do calculate. So this is 1,260 over x plus 20 and 1,200 over x. So just by filling in my table, I'm sure that I have answered a bunch of the questions on the first page. So we can go back to the first page and see if we've answered those questions. So if we go back here, if the average speed is this, state an expression for the average speed from Winnipeg to, yes, so the Winnipeg to Red Deer we said was x. Then it says write an expression in x for the time taken to fly from Red Deer to Winnipeg. On our table that was 1,260 divided by x plus 20. And then write an expression to fly this on the return journey. So the time there was 1,200 divided by x. And then it says calculate the average speed of the plane from Winnipeg to Red Deer. This is what step we're on right now. Okay, so let's go back over here. So the times are equal. It says in the same amount of time. So that means that they are equal. So this time equals this time. So because I have fraction equal to a fraction, this is crisscross. So I do criss, 1,260 times x equals cross, 1,200 times x plus 20. Okay, so I'm going to have a nice linear equation here. So on this side here, I just have 1,260x, and on this side here, I'm going to apply the distributive property. So 1,200 times x plus 1,200 times 20, 24,000. So I want my x's on one side and my number on the other because it's a linear equation. So that's gone. So 1,260 take away 1,200 is just 60x equals 24,000. So then I just have to divide both sides by 60 to get x by itself. So x is equal to 400. So 400 is the speed of the plane from Winnipeg to Red Deer. Okay, so now that I know that x is equal to 400, I can go back to the other page and just answer the remaining questions. Okay, so over here it says calculate the average speed of the plane from Winnipeg to Red Deer. So that was the x, so that is 400 kilometers per hour. Then it says calculate the flying time for Red Deer to Winnipeg. So the time from Red Deer to Winnipeg was 1,260 over x, which is 400, plus 20. So that's 1,260 divided by 420. So I'll just put that into my calculator, and I get that that is 3 hours. Okay, and then it says calculate the flying time for the 1,260 kilometer return journey from Winnipeg to Red Deer. So for that one, actually the return is the 1,200. So if I do 1,200 divided by x, so 1,200 divided by my x, which is 400, that would be 3 hours. But I have to go an extra 60 kilometers an hour. So the time that it flew, because it says it flew 1,200 in the same time. So I have to go an extra 60 kilometers. So if I have a speed of 400 kilometers in 1 hour, I want to know how long it's going to take to do those extra 60 kilometers equals question mark. So I can use cross multiply and divide to figure out how much above that 3-hour mark is it going to be. So I can do cross multiply and divide. So I can do 60 times 1 and then divide that by 400, and that is 0.15 of an hour. So altogether, it's going to take the 3 hours and the 0.5 of an hour, but let's figure out how many minutes that is. So if I times that by 60 minutes in an hour, that ends up being 9 minutes. So the total journey would be 3 hours and 9 minutes. Okay, so if you didn't like to do it that way, what we could do is just do 1,260 kilometers equals how many hours when 400 kilometers is the speed in 1 hour. That would give us the same answer. So if you did 1,260 times 1 divided by 400, that would also give you the 3.15, which is 3 hours and 9 minutes. So 2 different ways that you could do the same question. So that's the end of lesson number 10. I hope this video helped, and I wish you luck on your test.